Hi, welcome to lesson 2.2, Estimating Instantaneous Rates of Change. That is going to be a very key word for us in this course. We're just going to be estimating instantaneous rates of change. So please make sure you get accustomed to writing estimating or the estimate of, because that's going to be coming down on most of these problems here. So we'll take a look at a couple different types of rates of change. One of them is the average rate of change, which is the change in the quantity given by the dependent variable divided by the corresponding change in the quantity represented by the independent variable. So for any function y equals f of x, we see the average rate of change is f of x2 or y2 minus f of x1 or y1 all over x2 minus x1. Hopefully you will recognize that as the formula for slope, which you've seen in past years. Another little definition here, the instantaneous rate of change is the exact rate of change of a function y equals f of x at a specific value of the independent variable x equals a. Estimated using average rates of change for small intervals of the independent variable very close to the value x equals a. Okay, so we're actually just going to be estimating the instantaneous rate of change by using average rates of change. So we're going to be using this formula over and over and over again to estimate the instantaneous rate of change. Okay, so let's take a look at a first example here. This guy Andrew is draining water from a hot tub. It holds 1,600 liters of water. It takes 2 hours for the water to drain completely. And the volume in the tub, or the volume remaining, that's very key, is given by this formula, where the volume is in liters and at t minutes between 0 and 120 minutes. So first thing we're asked to do is determine the average rate of change of volume during the second hour. So what we want to do is take a look at this table of values and take a look down at the minutes, and they're broken up in 10-minute intervals. And so we can choose which range of values are in the second hour. So which range of values would be that second hour? Okay, so what we're going to do now is, we know the average rate of change again. I'm not a big fan of short forms. Av for average, okay, that's fine, but please write out av rate of change. And we see that that's going to be delta V over delta T. Okay, the rate of change of volume over time. And if it's in the second hour, what values are going to be used in the second hour? V of 120 minus V of 60 all over 120 minus 60. V of 120, as you can see here, is 0. And V of 60 is 400. And those two values are calculated by substituting the values in this formula, values for time in that formula. So we've got 0 minus 400 over 120 minus 60, which is negative 400 over 60. Now, generally speaking, again, not a big fan of decimals. However, in this case, negative 400 over 60 doesn't really give us a good sense of what is happening with the volume. So we can divide that to get a value of negative 6.667 liters per minute. So the change in the average rate of change in volume is negative 6.667 liters per minute over that second hour. Okay, so a little therefore statement. During the second hour, the average rate of change in volume is negative 6 point, we can say 66 repeated, or negative 6.67 basically liters per minute. Okay, so let's now move along. The second question of this is determine the instantaneous rate of change at exactly 60 minutes. Well, for the rate of change, notice up here we said that the instantaneous rate of change is the exact rate of change, and we're going to be finding estimates of the instantaneous rate of change, because right now you don't know the math to find the exact instantaneous rate of change. And to estimate the instantaneous rate of change, we're going to be using average rates of change for small intervals of the independent variable close to that value of A. Okay, so we're going to be using this formula for small intervals of values very close to x equals A, and in this case, that x value, that the independent variable, is going to be 60. Okay, so very close values very close to 60 is what we're going to be investigating here, using the average rate of change formula. Okay, because that's the only formula for rate of change that you know thus far. Okay, so let's take a look at this now. Since the rate of change depends on 2 points in order to calculate slope, it is impossible to calculate instantaneous rate of change at an exact time of 60 minutes, which is just 1 point. Okay, so you need 2 points to calculate the rate of change. Thus we use a preceding interval, which is technique 1, part A, in which we're going to be using the values of t between 59 and 60. So it's very close to that target value of 60 that we were talking about before, and we're using small intervals around that. To calculate the average rates of change for different values of t1, while t2 is going to stay at 60. Okay, so when we use t1 and t2 for the formula for the average rate of change, T1 and T2, T1 is going to continually change, where T2 is going to stay at 60. So we're going to start T1 at 59 and gradually increase that value of T1 towards 60. Okay, and here's the formula again, just to refresh your memories. So we're going to fill in this table, and so the first interval is from 59 to 60. So we want to calculate delta V, and we also want to calculate delta T. And then we're going to, of course, divide delta V by delta T. So V of 60 minus V of 59 is 400 minus 413.444. The more decimal places you hold in these stages, these steps, the better for more accuracy. Okay? So we substitute 59 into T here, and we calculate that, and we get 413.444, and then we subtract there, and we get negative 13.44444, and we get 60 minus 59 for delta T, and then when we divide them, negative 13.4444 divided by 1 gives us negative 13.444.